Okay, so this video we're doing example number 4. The graph of the function y equals f of x has been transformed by a series of stretches and or reflections. Write the equation of the transformed function g of x. Okay, so the red one is the original one and the black one is the transformed one. So if you look at the table on the right, it is giving you the key points for f of x. Okay, I think they're all the ones that I have dots at. Okay. And they've shown you that 1, 5 gets transformed to negative 2, 5 on function g of x. So what does it look like is going on? All right, well, if you take a look, your y coordinate's not changing at all. So there's no change in y. The change is only on x. Now notice you're going from a 1 to a 2, so you have a horizontal expansion of 2, right? And also notice that you're going from a positive number to a negative number, which means that you have a horizontal reflection, okay? So if we apply those transformations to all the points on the table, then we're going to do a horizontal expansion of 2 and a horizontal reflection on each of the points, okay? So if you look at 2, 5, you're going to take the 2, you're going to times it by 2 and make it negative, so you're going to have negative 4 and 5. And then you look at the 3, you're going to go 2 times 3 is 6, and you're making it negative, so you're going to have negative 6 and 2. And then 4 and 3, you're going to go 4 times 2 is 8, make it negative, you're going to have negative 8 and 3. So what are you doing to each of your x coordinates? You are timesing it by negative 2. And so you get a mapping notation that the point xy gets transformed to negative 2x and y. So has the orientation changed? In other words, is there a reflection? Yes. In which direction? Into the y-axis. Okay, in other words, you have a horizontal reflection. Has the shape changed? In other words, has it been stretched? Yes. In which direction? Well, about the y-axis. Okay, and we've stretched it by a factor of 2, right? So it's an HE2. Okay, so by how much? A factor of 2. Now, let's just take a look at what that means in terms of what our B value is. Okay. So you know for a horizontal stretch that it's 1 over the absolute value of B. Okay, so we're trying to find out what B is. Now whatever 1 over the absolute value of B is, we know it's going to give us a horizontal expansion of 2, right? So we're going to put that over on the right here. So I'm going to say 1 over the absolute value of B equals 2. So the question becomes, what is the value of B in 1 over the absolute value of B if I'm going to get a 2. All right, well, I can't put a 2 in there because if I put a 2 in for B, then I get a half. So I'm going to guess that it has to be a half, right? Is that going to give me 2? Is 1 divided by a half going to give me 2? Yes. So I know then that my B is equal to 1 over 2. Okay. So now I can come up with the equation. Okay, now I know that the form is y equals f of bx. Okay, now my function is g of x, so g of x becomes f of, and then b is a half, right, x. All right, but what have I not taken into account? I have not taken into account that I have a horizontal reflection, so it's negative 1/2 of x, okay? And so I'm just going to write this over here in red, that B, because we have a reflection, is negative 1/2, okay? All right, and let's go to the B section for this. Okay, so we have a base function, f of x, which is not shown on the graph. What must it be? And then add it to the graph. Well, we're given the key points of our base function. Our base function f of x has key points at negative 3 and 3. So I'm going to do that in red. So negative 3 and 3, 0 and 0, and 3 and 3. All right, I'm just going to write those coordinates in. And I'm going to join my points. Okay, and so what does this look like? It looks like an absolute value function, which it is. So the equation for it is y equals the absolute function of x. Okay, so the blue graph is g of x, and it is the transform graph of the red one. Okay, so in order to find the key points for g of x, or I should say the transform points of g of x, you need to be able to find some corresponding points on the blue graph that correspond with the red graph. Okay, so I'm going to look at this one. That's our first point here. Okay, where is the corresponding point on the blue graph? Well, I'm just going to draw an arrow straight down from the red point until it hits the blue graph, and that would be right here, which is at negative 3 and negative 9. So it becomes negative 3 and negative 9. Okay, well, this time we can see that x is not changing. It stays the same, but y is changing. It looks like I'm going from 3 to 9, so I have a vertical expansion by a factor of 3. And it also looks like I'm going from a positive number to a negative number, which means I have a vertical reflection. Okay, so if I take these transformations and apply them to all the points, well, 0, 0 with a vertical expansion of 3 and a vertical reflection, it stays 0, 0. Nothing changes there. And 3, 3 becomes, and remember, we're only applying it to y, so x stays the same. And I'm just going to go negative 3 times 3 is 9, with a vertical reflection is negative 9. So what is my mapping notation for that? My mapping notation for that is x, and it looks like I'm multiplying all of my y coordinates by negative 3, so negative 3y. So has the orientation changed? Is there reflection? Yes. In which direction? Over the x-axis. Has the shape changed? In other words, is there a stretch? Yes. In which direction? About the x-axis. By how much? A factor of 3. Okay, so it looks like, if you recall, the base formula for a vertical stretch is y equals AF of x, right? Okay, so that means that if I'm going to change all of my y coordinates by negative 3, it looks like my A value then is negative 3. And so what's my equation? My equation is y equals negative 3 times the absolute value of x, because that's my base function, right? The absolute value of x. And of course, I can also write it as negative 1/3 y equals the absolute value of x. Both of them are correct. Okay, I just want to throw a couple of examples in. I'll try to get through them quickly, just to kind of work from scratch. Let's say I give you y equals the square root of 2x, and I want you to graph that. Okay, well, it might be helpful to know that the parent function for this is, or the basic function is y equals the square root of x. Okay, and if you recall, when you graph it, okay, I'm just going to go up to 4 on the x-axis and up to 2 on the y. If you recall, the graph of the basic function, or the parent function, is at 0, 0, 1, 1, and 4, 2. Okay, so that's y equals the square root of x. If I want to graph y equals the square root of 2x, then maybe I want to know what the transformation is, right? So I look at this and I go, well, I have a 2 on the x, which means that I have a b value, which is 2. And if I have a b value, which is 2, my stretch is 1 over the absolute value of b, which is 1 over the absolute value of 2, which is 1 over 2. So I have a horizontal compression of a half. So what that means is that my x coordinate becomes half of what it was before. Okay, so if I look on my graph here, I've got 0, 0, 1, 1, and 4, and 2. And if I have a horizontal compression of a half, that means that my x coordinate gets changed by a factor of a half. So at 0, my x coordinate is 0. A half times 0 is 0, so that doesn't change. My next coordinate is 1, 1. My x coordinate is 1. Half of 1 is 0.5, so I can move it to here. So it's half the distance closer to the y-axis. And then my third point is 4, 2. Half of 4 is 2. So I shorten the distance from the y-axis to 2. And my new coordinate is 2 and 2. And there is my transform graph. Y equals the square root of 2x. Okay? All right, and then let's quickly take a look at a absolute value function, okay? And let's say that our base function is y equals the absolute value of x. What I would like you to graph is y equals 2 times the absolute value of x, and y equals 1/2 the absolute value of x. Okay, so let's start with our base function. Here's our graph. We're going to go up to 2 and -2 on the x-axis, and we're going to go as high as 4. So 1, 2, 3, 4 on the y-axis, and 1, 2, 3, -4 on the y-axis. Okay, so our base function has points at 0, 0, 1, 1, 2, 2. Okay, so 2, 2, 1, 1, 0, 0, -1 and -1, and -2 and positive 2 and positive 1. Okay, so we have this. Okay, so this is y equals the absolute value of x. All right, so for the black graph, our a value is 2, which means we have a vertical expansion by a factor of 2. All right, so that means that all of my y coordinates have to double. So let's take a look at the far left. We have -2 and 2. I'm going to double my y coordinate from 2 to 4, so at -2 and 4. Our next coordinate is -1 and 1. I'm going to expand my y coordinate to 2 because I'm going to go 2 times 1 is 2, and so I have a point here at -1 and 2. 0, 0 stays the same because the y coordinate is 0. 0 times 2 is 0. My next point is 1, 1. 1 times 2 is 2, so I'm at 1 and 2. And then 2, 2, remember I'm only changing the y coordinate. 2 times 2 is 4, so I'm at 2 and 4. Okay, so this is my next graph. If you have graph paper, it will look way nicer. And this is y equals 2 times the absolute value of x. Okay, now the red graph, 1/2 the absolute value of x. So a equals 1/2. We have a vertical compression of a half. That means that all of my y coordinates will become a half. And actually, why don't I change this just so it doesn't look too messy? Why don't I put a negative in front of the half? So I have a vertical compression of a half with a vertical reflection. Okay, so everything gets reflected over the x-axis, and my y distance becomes half of what it was before. All right, so let's take a look at our far point again on the left. We've got -2 and 2. We're going to take the positive 2 and we're going to times it by -1/2, and that means I'm at -2 and -1/2. Okay, wait a minute, not -1/2, -1, sorry, because 2 times a half is 1, and so I'm at -1, right? Okay, so -2 and -1. Okay, so my next point is -1 and 1. 1 times a half is a half, and I want to reflect it over the x-axis, so it becomes -1/2. So I have a point here at -1 and -1/2. And 0, 0 does not change because 0 times -1/2 is 0. And then 1, 1. The y-coordinate is 1. 1 times a half is a half, reflected over the x-axis, so I'm at 1 and -1/2. And then the far right point, 2, 2, 2 times a half, and then reflected over the x-axis, and it becomes -1. So we're at 2 and -1, and I draw a line through there. And this is the graph of y equals -1/2, absolute value of x. Okay, that is it. That finishes horizontal and vertical compressions and expansions.